Hello, good morning, guys.
Good morning, sir.
So in the last class, we discussed about your DHCP protocol, DNS. Then we discussed about FTP and TFTP. Okay. So DHCP stands for Dynamic Host Configuration Protocol. So this particular protocol is used to dynamically assign IP addresses to the client systems. Okay. Used to assign dynamically assign IP addresses. So to assign dynamically the IP addresses, it undergoes 4 message exchange. There are 4 messages that are being exchanged, and those are the DORA messages. D stands for discover, O stands for offer, R stands for request, and A stands for acknowledgement. Okay, this discover message is sent by the client. First of all these messages are broadcast. Why? Because your client will not be having any IP address, so the client cannot use any IP address. So server doesn't know where is the client, and client doesn't know where is the server. Okay, so as long as client is not having the IP address, all the messages will be broadcast. Discover message is generated by the client, okay, to discover the DHCP server, if whether DHCP server or more than one DHCP servers are available in your network or not. So this is the first message. Then once this message reaches the DHCP server, the DHCP server is going to offer IP address and IP configuration. Okay, it is going to give information about what is the next IP address it can assign, what is the subnet mask, what is the default gateway, as well as the DNS. These informations means whatever configurations you have done in your DHCP server, all the same configuration your DHCP server is going to assign. Then R for request. Your client is going to, before accepting the IP address, your client first, it will generate a GR to check whether the address provided by the server is being used anywhere in the network. If it is not used, your client will show the acceptance by sending this request message. And once your DHCP server receives this request message, it is going to make an entry in the DHCP binding database, and it is going to acknowledge the client that the client can use this particular address. Okay, open. Okay, then we discussed about DNS. DNS stands for domain name service or domain name system, right? So this DNS service is used for IP to name or name to IP resolution. Okay, if you have the name of a particular website, then your DNS service is going to provide you the IP address, and if you are providing the name, it is going to provide you the if you provide the IP, it is going to provide you the name. Okay, in your Windows system also you can check. There is a utility known as NSLOOKUP. Okay, so once I say google.com, it is going to provide me the IP of Google, and if I give this IP, it will provide me the name. Okay, this is clear. So name to IP and IP to name resolution. Because in your DNS server, there are 2 types of zones. One is the forward lookup zone and one is the reverse lookup zone. Okay, there are 2 zones in your DNS server: forward lookup zone and reverse lookup zone. In short, you call them it as FLZ and RLZ. FLZ is forward lookup zone. This forward lookup zone is used to resolve your names to IP. Okay, means name to IP resolution configuration will be in the forward lookup zone, and this is reverse lookup zone. This will resolve IP to name. Is that clear? Then we discussed about the FTP protocol. So FTP is a file transfer protocol. It is used to transfer files between devices, one node to another node. Okay, and it uses TCP port number 20 and 21. Then we discussed about the TFTP. It is also a file transfer protocol, but it is known as trivial file transfer protocol. Okay, it is an unsecure file transfer protocol, and your FTP is a secure file transfer protocol. Okay, so the TFTP, it is basically used for taking backup of configurations and IOs. And yesterday we saw the practical how you can take backup and restore of your configurations of your device, and how you can backup and restore the IOs of your, correct? Okay, and yesterday I gave you a question: when your DNS uses port number 53, TCP and UDP. Did research? No? Okay, let's postpone it. Okay, so today,
yes, I found the answer.
Yes, please tell me.
So DNS will fall back to TCP when the packet size is too large to push with the UDP.
Yes, it is. So basically, there is a size 512 bytes. Okay. So if the data size is smaller than 512 bytes, it is going to use UDP. And if it is larger than 512 bytes, it is going to use TCP for reliable communication. Okay. Yes, packet size. Okay.
How it will determine that so we are using UDP for transfer like streaming process and all.
Yes.
Is it
DNS queries, they are resolved by your UDP, right? But again, there is something when you're discussing about DNS server. Right now, we discussed about the zones, forward lookup zone and reverse lookup zone. So there is a process that is known as zone transfer. From primary DNS server, you forward the zones to your backup DNS server or secondary DNS server. So that time when you're transferring zones, the size of data could be larger than 512 bytes. And there it has to use TCP for reliable transmission. Okay. So during zone transfer, it uses TCP and then DNS queries, UDP.
Which kind of zone means?
See, there are two zones in your DNS server. Right now, we are not discussing about the configuration of your DNS server because these zone transfers you will configure in the like your Windows servers and Linux servers. Okay, so we are not going with the server part right now. This is that we are having two zones in the DNS server, right? And there are two DNS server. One is the primary and one is the secondary. Okay, so all the configurations you are going to do on the primary DNS server. Then you are going to configure the secondary DNS server so that in case your primary DNS server goes down, your secondary DNS server is going to resolve your queries. But it must have the zones, right? Whatever zones FLZ and RLZ you have on your primary DNS server, those same zones should be available on this particular server also. And that is why, in your systems, you always assign one is the primary DNS and one is the alternate DNS. If you check in your Windows, preferred DNS and alternate DNS. This is the reason you assign two DNS here. Preferred DNS means this will be address of your primary DNS server. In case your primary goes down, if there is no information available for primary, then you will go with the alternate DNS server. Okay. So the alternate DNS server should also have the same entries. And for this, it should have the zones. So you will be transferring your zones from primary to secondary. And that time you will need the TCP. Okay. Is it clear?
UDP is an unreliable.
Yeah. So that is why DNS, it is using it for DNS queries resolving, right? So sometimes you get it, sometimes you don't get it.
Yeah.
You're going to make the request again, right? All right. So next we'll be discussing about VLANs. And before going to the VLAN, we'll have the introduction to the switch again. Okay. So your switch, it is a layer 2 device, right? Switch is a layer 2 device. Layer 2, which what is the name of the layer 2? Data link layer, right? Okay. Then your switch is a intelligent device. Why it is an intelligent device?
It will store the MAC and
It has, or your switch can store some information, right? It can store information. And based on that information, your switch can make forwarding decisions, right? So this is why your switch is an intelligent device, means it has some sort of database that is telling the switch that which particular port, let's say this is port number 1, so a device A is connected. So switch has this information. So whenever a traffic is coming for this particular destination, your switch will forward that particular traffic only to the port 1. Okay, so switch can make forwarding decisions based on this information, and this information usually we call it as a MAC address table, or sometimes you'll know it as a CAM table. Clear? Then your switch has a single broadcast domain. What does it mean? Means if there is any broadcast on any port of switch, your switch is going to forward this particular broadcast traffic on each and every port, except the port it was received. It will not send it back to the same port. Why? There is some rule called as split horizon. Just to prevent the loops, it will not forward this particular message on the same port. Okay. Then your switch has active port collision domain, means all the active ports of your switch are having separate collision domain. So there is less chances of collision. Okay. And switch is a full duplex device, means switch can have bidirectional communication at all the times. Okay. All right. Now we'll consider a scenario, and then we'll discuss about the VLANs. So I have a small company, and in my company, I'm having only 4 systems. Okay. These are the four systems. This is switch. And this is PC1, PC2, PC3, and PC4. Okay. Let's assign IP addresses. This is, let's say, 10.0.0.1 and MAC address is A. This one is 10.0.0.2, 10.0.0.3, and 10.0.0.4. MAC address is B, C, and D. This is clear? Yes, please. So right now, my all four systems in my company, they'll be having the communication, right? Because they are in the same network, connected to a switch. So they will have communication. Now, what I need to do, I want to divide my network into two different departments. This is one department. This is second department. Okay. And let's say this is my HR department and this is my sales department. Okay. This is clear. Now I want that my two departments should not communicate with each other. My requirement is they should not communicate with each other. So what I can do? They should not communicate with each other.
Break the broadcast domain.
Break the broadcast domain. How? Yeah, how? Switch is a single broadcast domain device, right?
Yes.
But we are not talking about. We are not talking about VLANs yet.
We can
we-
use ACL.
ACL. No,
That's what from the router.
router we are not having.
Okay.
Right now, this is the scenario. You have a switch. You have two departments.
Network, we can provide different.
So we can, what we can do? We can provide different network IP. Means one network we are using this side. Let's say in HR department, I'm using the 10 network. In sales department, I can use 20 network. Correct? Let's check. So we can say this become 20.0.0.1, 20.0.0.2. So first question is it possible to have two different networks on a switch? No? Why?
Yes.
Okay, yes. Other students?
Yeah.
No, your yes.
Yes, we can have different. Did you mean to say different networks can traverse through, or what exactly?
No. We are not talking about communication. I'm just
Okay.
talking about the scenario. Can we configure a network like this? That we have a switch and we can use two different networks on the switch.
We can.
We can. Obviously, we can. Why? Because your switch does not depend on the IP addresses. So switch doesn't know which network they belong to. Switch does not know which network they belong to. So again, there is no problem configuring a network like this. So will they communicate with each other? No. Why? Because switch provides communication in the same network only. Means your 10 system, 10.0.0.1 will be able to communicate with 10.0.0.2. It will not be able to communicate with 20.0.0.1. Then your 20.0.0.1 will be able to communicate with 20.0.0.2. They will not be able to communicate with 10.0.0.2. These two networks are separated now. They will not have the communication. Requirement is fulfilled. Requirement was they should not be able to communicate with each other and they are not communicating. But still there is an issue. What is the issue? That your switch, it is a single broadcast domain device. Correct? So what will happen if there is a broadcast? If your PC1 creates a broadcast, what will happen? Your switch is a single broadcast domain device. So whatever broadcast message coming on one port of switch is going to forward it out all the ports. Because switch doesn't understand what IP addresses, so it doesn't know if it is a different network or what. So this same broadcast message will be traveling to all the departments, right? So first thing, this particular sales department doesn't have anything to do with the traffic of 10 network, but still it is getting extra traffic. Means extra bandwidth is being used. Then the host in your second department, they will have to process this message. Why? Because it is a broadcast. They will have to open the packet and check whether for which network or which IP this particular broadcast message is, right? They will have to check the information. They will use their own CPUs as well. So extra bandwidth, extra CPU. Then the third, security issue. Anything from HR department, why should it should travel on the sales department? So again, security consideration is also there. Clear? To prevent this broadcast traffic from traveling one network to another network in a switch, we are going to break the broadcast domain of the switch. We are going to convert the switch from single broadcast domain to multiple broadcast domain. Okay. And how we are going to do that? We are going to do that with the help of VLANs. Your VLAN stands for virtual LAN. So initially, if I use same network on all the devices, that will form a complete LAN. right? But right now, if you see, we are having two different networks, means these are two different LANs. But again, instead of using two switches, we are just using one switch, right? So with the help of VLAN, what we are basically doing, we are configuring this switch in such a way that this switch is going to behave like two different switches. This switch is going to behave like two different switches, and each of the switches are going to have a LAN. So this is not physical switch. We are breaking this switch into two virtual switches, and the LAN that will be forming, that will known as VLAN, virtual LAN, virtual local area network. Is that clear?
I will just one more.
Yes, please.
So previously when you said that when we differentiate these networks
Hmm.
without doing the VLAN, then PC1 can access PC3 also, right?
No, only the broadcast traffic will be traveling. Other traffic, unicast traffic will not be traveling.
If I purposefully give,
Yeah, if you
ping
go
to
on,
20
yes,
dot
if you try to go and say ping 20001 on PC1, what will happen? First of all, your PC1 is directly going to send this message to your gateway, different network. So let's say if it is having gateway 10.0.0.100, where is the gateway? So there's no gateway.
Correct.
No gateway means no different network communication. So your PC1 itself will drop the particular message. Okay, this is clear. And even if you have the router, and if you haven't configured something known as inter VLAN routing, then there will be no communication.
because it is connected with only one network.
Okay, is it clear? So for inter VLAN communication between different VLAN, we are going to require inter VLAN routing. Okay, this also we'll discuss, but first of all, let's understand about VLANs. So what is VLAN and why do we require VLAN? Is it clear? Yes, online people?
Yes.
Yes, sir.
All right, now let's go and check about the VLANs.
No, we cannot connect PC1 to PC3.
Say it again.
Even if we have a router,
Even if we have router,
we cannot ping from PC1 to PC3.
yes, you can ping, but for that we have to configure inter VLAN routing. Okay, there are different methods to configure inter VLAN routing. Like first is a router with a separate interface. Means for each and every VLAN, we will have to use different interfaces. If we are having two VLANs, VLAN 1 and VLAN 2, we have to use two interfaces of router to provide communication, right? Because two different networks. So first is router with separate interface. Second will be router on a stick. Means we'll just perform the task with one interface. So that will be router on a stick. And third, it will be layer 3 switch. Means instead of using layer 2 switch, we can go and use layer 3 switch. And layer 3 switch will provide the communication between two different VLANs. Why? Because your layer 3 switch has the routing features. Okay, your layer 3 switch has routing features. And what is routing? Communication between two different networks. That's it. Is it clear? Okay, so we'll be seeing this method. Okay, and if we have time, I'll tell you about these two also. This one is easy. This one is little tricky because layer 3 switch configuration you haven't seen. Okay, so if we have time, I'll discuss about all these three. Otherwise, in our syllabus, I'll be showing you this. Okay.
Which is communicated within the lane. It is not going to outside.
Repeat your question.
Which is an layer 2 device.
Switch is a layer 2 device, but there is different type of switches also. There's something called as MLS, multi-layer switch, or you can call it. See, there are purely layer 3 switch. There are multi-layer switch that are behaving L2 and L3.
Router.
Hmm.
So how traffic travels outside?
Outside means?
Public.
See,
Internet.
how can internet travel? So for that, you will need this multi-layer switch or your layer 3 switch. And these two types of switches, they have the routing features.
Okay, so we don't need any router if we have it.
Yeah, if you have a L3 switch, you do not need a router.
Everything could be configured. in
Yes,
that way.
even if you have a firewall, your firewall also has a routing features. You do not need a router if you have firewall. Okay.
Can we perform all the routing configurations in this switch? Every switch?
Yes, we can perform.
Including ACL and everything.
Exactly. Okay.
So we are putting two layer 3 switches and we can configure OSPF technology.
Yes, we can do that because they are having the routing features. So you can have two layer 3 switches and configure OSPF and everything. Okay. Okay.
Why are we still using router in that way?
Because see, all the features of router will not be available in your switch. All the features will not be available. I'm talking just about the routing features. I'm just talking about the routing features. They will be available. Okay. All right. So what is VLAN? VLAN is a custom network which is created from one or more local area networks. Means if you are having one LAN or multiple LANs, then you can divide that networks into virtual local area networks, VLAN, smaller network. Okay. For example, this is your network. Right now, this is in the same VLAN. We are having two switches, right? 1 and 2. Correct. So what will happen if there is a broadcast on this particular interface? It will be broadcasted this side, then this side. Now again, it received this side, and this side. So if you want that broadcast from this side, broadcast from one side should not travel on the other side. This broadcast should be limited here only. So you'll put these networks into two different VLANs, and then your broadcast will not travel this side. Okay. So it enables a group of devices available in multiple networks to be combined into one logical network. Okay, means let's say same scenario you consider. So we can have VLANs like, let's say this is 10.1 IP, this is 20.1 IP. So you can put them in one VLAN. Because in companies, what happens, all the system belonging to one department are not necessarily in one place only. Means if someone is accounts department or sales department, it is not necessary that they'll all sit in one room only. They can sit in different rooms. So in different rooms, we are going to require the VLANs, because we want that all the salespersons anywhere in the company, they should be able to communicate with each other. And all the HR department persons, they should be able to communicate with each other anywhere they are. Okay. So maybe one HR is sitting on the first floor, one is sitting on the second floor, one is sitting on the third floor. They are not in the same place. So what we are going to do, all the places, they are going to have separate switches, right? Your first floor will have switch, your second floor will have switch, or third floor will have switch. So you are not going to carry, let's say this particular port, some ports they have belonging to VLAN HR. So you're not going to carry cables, these big cables to each and every floor. Instead of that, you'll configure VLANs on these switches also. So whenever you connect, they will connect it to the same VLAN. They will become in the same network. Okay. When we do the configuration, this will be more clear. Okay. The result becomes a virtual LAN that is administered like a physical LAN. Okay. Because it is going to behave like a physical LAN only. Your VLAN is going to behave like a physical LAN only. The full form of VLAN is defined as virtual local area network, because we are dividing a single physical device into multiple physical devices. And each and every VLAN is a separate broadcast domain. Means broadcast traffic from one VLAN will not travel in the second VLAN. Is it clear?
So we can add two multiple networks in a single way.
Yes, we can add.
So that both will communicate.
No. See, if instead of 10.0.0.2, I have 30.0.0.2 and they are still in the same VLAN, they are not going to communicate. They will not have the communication. Why? Because again, your PCs, they are going to require default gateway for that. And if default gateway is available and the inter-VLAN routing is available. Okay. In this case, again, let's say this is 10 network, this is 30 network, this is 30.0.0.2, 10.0.0.2. So if I use one interface of router, this one interface can have one IP, either 10 or either 30. But again, there are two different networks. So I'll need two different ports. And then let's say these are in the same VLAN. Let's say VLAN 10. So these interfaces should also be in the same VLAN for the communication. If router interfaces are in the different VLAN, let's say VLAN 1, and these are in the VLAN 10, again, without inter-VLAN routing, we cannot communicate, right? So we should put them also in the VLAN 10. Now they will be able to communicate in the same VLAN, because router is the device that is providing communication between two different networks. Okay. The role of VLAN is not to separate anything, just to separate the broadcast domain. That's it. The role of VLAN is to stop broadcast traffic from one VLAN to another VLAN. Okay.
So the router can configure any path.
Router can configure any path means?
He can send to any of the networks, any of the.
Again, inter-VLAN routing. Without inter-VLAN routing, we will not be able to communicate. Okay. This is clear. Now, without VLANs, what will happen? So a broadcast sent from a host can easily reach all network devices, because your switch is a single broadcast domain device. So if there is a broadcast on any of the port of the switch, it is going to reach all the network devices. Each and every device will process the broadcast received frames, because they will have to open the frame and check for if the frame belongs to them. It can increase CPU overhead on each devices and reduce the overall network security, because some information from the one department is going to the other department. So, okay. In case if you place interface on both switches into separate VLANs, means if this interface and this interface I put in separate VLANs, They will not have the communication. So if there is a broadcast on this side, that will travel here and here will not travel this side. Okay. So if you place interfaces on both switches into separate VLAN, a broadcast from host A can reach only devices available in the same VLAN. Okay. Host of other VLANs will not even be aware that communication took place. Why? Because there is no communication coming this side. So they will not even know whether some broadcast happened this side. Is it clear? Okay. So VLAN in networking is a virtual extension of LAN. A LAN, what is a LAN? A LAN is a group of computers and peripheral devices which are connected in a limited area such as school, laboratory, home, office building. Okay. It is widely useful network for sharing resources like files, printers, games, and other applications. This is about a LAN. What is a LAN? Okay. Now, these are the ranges. These are the ranges of your VLAN. So VLAN ranges from 0 to 4095. Okay. Out of these VLANs, your VLAN 0, it is reserved for VMware. And your VLAN 4095, it is reserved for Apple Talk. Okay, these are protocols. So we cannot use them or delete them or create them. You will not be able to see these VLANs because these two are reserved. Then your VLAN 1 is known as the default VLAN. Why it is known as default VLAN? Because all the ports of your switch are by default in VLAN 1. So if all ports of switch are by default in the same VLAN, means this is one broadcast domain, because each and every VLAN is a separate broadcast domain. Okay. So VLAN 1 is the default VLAN. Again, you cannot create, delete this particular VLAN. Then from VLAN 2 to VLAN 1001, these are standard VLANs or normal VLANs. You can create these VLANs, edit these VLANs, modify these VLANs. You can do whatever you want. And you can also delete these VLANs. Okay. These are normal VLANs. Then again, VLAN 1002 to 1005, these are known as legacy VLANs. Okay. Used in different network topologies like your FDDI and token ring. Okay. So these are used for token ring topology, token ring networks. Okay. So again, we cannot create them. These are already created. So these VLANs you'll find already available in your switch by default. You cannot delete them if you want. Okay. Then again, 1006 to 4094. This is the expanded range of VLAN. Okay. So this is not supported whenever you see there is a protocol VTP, VLAN trunking protocol. Right now, we will not discuss about this. So VTP, it has two versions, VTP version 2 and VTP version 3. So whenever your switch is working on VTP version 2, you will be able to use these VLANs. And if it is working on VTP version 3, then you will be able to use all these 4094 VLANs. But again, this is reserved, 0 is reserved, 4095 is reserved, and 1002 to 1005 is reserved. So what are the VLANs we are going to work on? From 2 to 1001. In your CCNA, in your CCNP, you will be working on 1006 to 409. There will be no difference in the VLAN configuration, how you configure the VLANs, what is the use of the VLANs, how they work. No difference. Just the number is different. Okay. All right.
Jay, you said like
Yes,
legacy VLANs,
Yes.
those are also reserved, right?
Yes, those are reserved.
So we can't see those.
No, we can see them. You cannot see 0 and 4095.
Okay.
You can see VLAN 1, it will be already available. Okay. And these 1002 to 1005, these also will also be already available. Okay. You
So
can
you
see these
can't
VLANs.
edit or delete with the
Yes, we
reserved.
cannot delete these VLANs. Okay.
Nice. Thank you.
Sir, we can see this VLANs in switch, right?
Yes, we can see. I'll be showing you with the practical.
Sure.
Okay.
So can we edit those?
Which one? Which VLAN?
2 to 101, 2 to 1001.
Yeah, we can create, edit, modify, delete everything. These VLANs we can edit. You can see by default, you will not see these VLANs in the switch. Or let me just show you in the switch itself. We'll make it more clear. First of all, your switch is also having the same 3 modes: user execution mode, privilege mode, and global configuration mode. The commands will be same: enable, configure terminal, and enable and configure terminal, right? So let's say I'm taking this switch. If I open this switch, it is starting up. Which mode? User execution mode. If you type the enable command, privilege mode. Okay, spelling mistake. Enable command, privilege mode. Okay. Now, if you want to check VLAN configuration, what are the VLANs available? You can say show VLAN brief. Hit enter, and you'll see these are the VLANs by default available. VLAN 1, default VLAN, then VLAN 2, 1002 to 1005. These are the reserved VLANs. Okay. And you can see all the ports of your switch are by default part of VLAN 1. That is your default VLAN. Is it clear? Okay.
So whenever we use VMware, then
VMware protocol I'm talking about, not the software. Okay.
And we can use the same shortcuts as the rest of the.
Yes, same shortcuts and everything. Okay. Let's say you are in the global configuration mode. If you press Control Z, you'll go to the release mode. If you type the exit command, you'll exit the user execution mode. All commands are the same. Okay.
The extended range will be that.
Yes, we can create, edit, and delete. But if you see, your switch does not support VTP version 3 right now in your packet tracer. Okay. But if you are using GNS3 or EVNG, there it will support, and you can see the extended range of VLANs also. So right now, if I try to create VLAN, and if I give question mark, it is showing me the full range, but only between this range it is accepting. So if I try to say 4094, it will tell me extended VLAN not allowed in the current VTP mode. Okay. And if you check for the VTP version, if I say VTP version and question mark, it is supporting only VTP version 2, not supporting VTP version 3. So you will not be able to use these VLANs. Okay. So you can use between 1 to 1005. There is no issue. Clear?
So in
Yes, please tell me.
CCNP, will
Yes.
we use the
Extended.
what application are we going to use? Packet
Yes.
tracer? Or?
No, not packet tracer. You will be using one is GNS3 and one is EVNG. These are the applications you will be using, and mostly you'll be working on EVNG.
Okay.
Okay, because
What's the difference? What's
the
the
difference
difference
is
between
your
the two?
packet tracer is a complete simulation software. Okay, and this EVNG and your GNS3 they uses the real router IOs. Okay, so if they are using the real router IOs, you will find all the commands of the real routers and switches. Okay, see, let me just show you. So right now this switch is not supporting VTP version 3, right? But if I open EVNG, if I start EVNG, you'll see.
Is it free? EVNG.
Yes, it is free. Community version is free, but if you go for the professional, it is not free. But you can perform all your practicals and CCI in your community edition also. There is no issue. Professional will provide you access to more devices and configurations. 207.141. So for EVNG, there is a virtual machine. Okay. So you will have to provide you will have to create a virtual machine, and you are going to access that virtual machine. That is going to provide you the interface to use the devices and configurations. Okay, let's say this is the switch. So I'll just turn on this switch. So this is going to take some time. Let it come up. By the time we'll discuss our. Now, what is the application or purpose of VLAN? So VLAN is used when you have more devices on your LAN network. So you are having a LAN and there are multiple devices. So what you can do to reduce the traffic, to reduce the broadcast traffic in your network, you can break your network into different VLANs. Okay. It is helpful when you have a lot of traffic. Same thing, more devices means more traffic. VLAN is ideal when a group of users need more security or being slowed down by many broadcasts. So again, if you want to reduce broadcast or increase security of a network, you are going to create a VLAN. It is used when users are not on one broadcast domain. If you want that your users should be in the different broadcast domain, you will create the VLAN and separate the broadcast domains. And with the help of your VLAN, you make a single switch into multiple switches. And it means your single switch is behaving like multiple switches. Okay. So these are the applications and purpose of VLAN. What are the advantages? First of all, it can reduce the size of broadcast domain. So if you have a switch is having 24 ports, all 24 ports are in a single broadcast domain, right? But if you divide it into two different broadcast domain, let's say 12 ports you make in one broadcast domain and 12 ports in other broadcast domain. So earlier one broadcast domain was having 24 ports, and now one broadcast domain is having 12 ports. So do you see the size of your broadcast domain has been reduced? Okay. Then VLAN allow you to add an additional layer of security because traffic from one VLAN will not be traveling to other VLAN. Okay, not even the broadcast traffic. It can make device management simpler and easier. You can easily manage the devices into different VLANs. Okay, you don't have to worry about that this traffic is going on that side and that traffic from that side is coming on this side. Higher performance and reduced latency. Obviously, if there is less traffic in your network, less broadcast traffic in your network, more of your bandwidth will be free. Why? Because less bandwidth is used. So if more bandwidth is free, then you can have higher performance, you can have higher bandwidth to send the data. And if you have more bandwidth free, you are sending more data, means latency is reduced. VLAN provide increased performance, same thing, higher performance, increased performance. VLAN remove the physical boundaries. So in case if you want to use two different networks, you will have to use, in a general case, you have to use two different switches. If you want to create two different LANs. But when you create VLAN, one single switch will behave like two different switches. So this is like, earlier we were having a physical boundary that in one switch, we can have one LAN only. And now in one switch, we are having two different LANs. So this is removing your physical boundaries. It lets you easily segment your network. This is correct. It helps you enhance network security. Same thing, you increase the additional layer security or enhance network security. You can keep hosts separated by a VLAN. Again, this is the same thing. You do not require additional hardware and cabling, because if you have to create two different LANs, you had to use a different switch also. And for this different switch, you needed to use a cable also. So means extra hardware and cabling you needed if you are using two different switches. But when you're using one switch and creating VLANs, we do not require extra hardware or cabling. Okay. And this helps you save cost also. Clear? Let's see if your switch is already up. Yes, we can have multiple VLANs, not just two.
Is there any limitation?
No limitation. All 4094 VLANs you can create. Okay. But again, let's say if your switch is a 24 port switch, it is a 24 port switch, and you create 24 VLANs, they will not communicate. They will not communicate. So according to our requirement, we are going to create the VLANs. Number any you can create. Okay.
There is a limitation with this.
With the number of ports,
Yeah,
because if you have 24 ports and if you create 24 VLANs, how they will communicate? What is the use of using that particular network, right? Okay, so this is the switch. If you see here, show VLAN brief. So these are the default ones. Okay. Okay. I'll go to the global configuration mode. And if I say VLAN and give question mark, so you see, I get an option to assign any number of VLANs. Okay. So if I say VLAN 4094, I'm able to create. I can give this name, let's say sales. And if I go again and check, show VLAN brief. So you can see I have the VLAN 4094 also. Earlier, I was not having this VLAN, right? 1005 only. But now I have VLAN 4094. Why I'm having this? Because my this particular switch, it supports VTP version 3. Do you see? Okay. And this is a layer 3 switch. So you'll see if I say router OSPF, it is supporting the commands process ID. So this can behave as a router also. Clear? On the normal switch, on your layer 2 switch, if I go to an interface and try to assign IP address, let's say interface F0/1. And if I say IP address, it is not taking the IP address. It is saying unrecognized command. But on your layer 3 switch, you can say interface. What are the interfaces? Z0/0. You can say IP. Right now it is saying unsupported command. Okay. So what you can do? No switch port to disable the layer 2 features. Because by default, your layer 3 switch is also behaving like a layer 2 switch. And now if you see IP address, and if I give this no switch port command in this switch, no switch port, you see, it is not taking this command. Yes.
If you go to that layer 2 stage.
Sure.
So when you say that when you disable that switch port, so the switch will stop acting as a switch and it will start acting as a router.
It will stop layer 2 features on this particular interface.
So we cannot use both.
We cannot use both means.
I mean, routing options and layer 2.
How can you use? See, you can use the options. We are just talking about this particular interface. So means from this interface is behaving like a layer 3. Okay. So if this interface is behaving like a layer 3, means you can create this interface or use interface as a gate. This is a layer 3 switch. Okay.
So we can perform all the,
Switching as well as
as
routing.
well as-
Yes. Okay, let's wait for a while. There's electricity issue. Thank you for reminding. Okay. So next we have the switch ports. So if we discuss about the ports on a network switch, the switch port is a physical opening where you connect the data cable, right? Generally, the switch ports are rectangular on the 3 sides with a V-shaped pointer on either top or the bottom. Because why we are saying top or bottom? If you check here, so these ports are available in 2 directions, right? This side you see the V shape and also in the bottom side. Okay. So this is why sometimes you'll find it up and sometimes the V shape will be in the bottom. All right. Then according to your VLAN, we have 2 types of interfaces or 2 types of ports. One is the access port and second is the trunk port. If we discuss about your access port, so access port is the port that is member of a single VLAN only. This is a member of single VLAN only. And it can forward traffic of a single VLAN. Okay. So if we consider a switch and if a switch is having 24 ports, so by default, all ports are in VLAN 1. So all ports are in VLAN 1 means they can forward the traffic of VLAN 1 only. Means they are acting as a access ports. So by default, all ports of your switch are behaving as an access port and they are in VLAN 1 means they will forward the traffic of VLAN 1 only. So if there is any traffic from any other VLAN 20 or 30, your switches or these ports are not going to forward this traffic because they are behaving as an access port and they will forward the traffic of the VLAN they are in. Means if I have port 1 on the switch, that port 1 belongs to VLAN 10. So this particular port will forward the traffic of VLAN 10 only. Okay. This is one point. One more point. Your host, let's say this is a switch and I have connected a system here. And this particular port is in VLAN 1. So your system will never know which VLAN it is in. Your end host are never aware of the VLAN configuration. They don't have anything to do with the VLAN. The VLAN concept totally belongs to the switches. These hosts, they will forward the traffic normally as they always do because they are not aware about the VLAN configuration. Is it clear? Okay. Next, let's say we want to forward traffic of multiple VLANs. So if we consider 2 switches and let's say we are having VLAN 10, VLAN 20 and VLAN 30 and similar VLANs we are having on the other switch 10, 20 and 30. Now from this switch to this switch, we want the communication. So we'll connect a cable. All ports by default in access mode. So this is also in access mode and this port is also in access mode. And by default, they will be in the VLAN 1. This will be also in the VLAN 1. Second will also in the will be also in the VLAN 1 only. Right. So whenever a traffic from VLAN 10 is coming this side, what will happen? This port will drop this traffic. Why? Because this port is working as an access port and can forward only data of VLAN 1. Okay. So to forward traffic of multiple VLANs, we have a second type of port that is a trunk port. Okay. So by default, your trunk port is a member of all the VLANs. Okay. So you can say your trunk port is by default member of all VLANs. Your trunk port is by default member of all the VLANs. Means can forward traffic of all the VLANs. So looking at this, we can say that access port we can use to connect end host and trunk port we can use for switch to switch connectivity. So if I create these 2 ports as trunk ports, what will happen? These ports will become member of all the VLANs by default, means they will forward the traffic of all the VLANs. So whenever traffic from VLAN 10 is coming, 20 is coming and 30 is coming, they are going to forward this traffic. Is it clear? Access port and trunk port. Now let's see about the ports. So an access port connect to a network host to a single VLAN. Okay. An access port connects a network host to a single VLAN and manages data traffic for that virtual network. You see, single VLAN and only manage traffic for that particular VLAN only. Okay. Because data can only go back and forth on the designated VLAN and access port handles untagged Ethernet frame. So this tagging and untagging, for this we'll study 2 protocols. One is the ISL and second is the 802.1q. So we'll be discussing these in the coming session. What is tagging and what is tagging and what are these tagged frames, when they are tagged, when they are not tagged, this thing. Then we have the trunk port. So trunk port usually connect to another switch, means between switch to switch connectivity. And it's able to interact with several VLANs. So by default, your trunk port is member of all the VLANs and can forward the traffic of all the VLANs. On a complex network with multiple VLANs, a trunk port manages data transfer to and from those virtual networks. Means again, two switches you are having multiple VLANs on switch 1 and same VLANs on switch 2 also. So it will be sending the traffic if these are the trunk ports. Okay, these two interfaces, these trunk interfaces will be providing communication between these two switches. To do so, a trunk port recognizes frame tags. Again, this tagging thing we'll discuss about when we are discussing about ISLN 802.1. Okay, that specify the intended destination of the data. So basically, if you want to understand the word tag, you can say whenever traffic is going through the switch, this switch will say this traffic belongs to VLAN 10. It will put a tag. Okay. And this side, when this reaches this switch, it is going to remove that tag. Again, when this switch is replying with any, let's say VLAN 20, so it is going to tag and it is going to remove the tag. Okay. So this will be more clear when we are discussing about these two protocols. So maybe tomorrow we'll be discussing about this trunking. Is it clear? Now we'll see how we can create the VLANs, delete the VLANs, and provide membership to the switch ports. Okay. So first of all, we are going to see how to create the VLANs. VLAN creation is very easy. Yes, please.
So this trunk port that you mentioned, it works on different switches or a single switch?
How? Can you repeat your question? Like
Switching between the different VLANs, right? To communicate between different VLANs.
it is basically used for switch to switch connectivity.
Okay.
Means
so
whenever,
different switches.
yes, even on a single switch, you can have a trunk port. Like when we are going with the router on a switch inter-VLAN routing,
Yeah,
that time we'll be using only one switch, one router, right? And that time we'll be creating a trunk interface to the interface connecting to the router. Okay, so right now you'll get confused. Let's do some practicals and then we'll understand. Okay. Okay, so we are going to create the VLANs. So to create the VLANs, you'll go to the global configuration mode. Commands are very simple. You are going to say VLAN and the number of VLAN. Let's say I want to create VLAN 10. Okay, hit enter. Done. Only two commands are there for VLAN. One is the VLAN and VLAN ID. And second is if you want to give the name, you can give the name. Let's say HR. Then I can create VLAN 20. Name sales. I can create VLAN 30. Name accounts. Okay. Only these are the two commands to create the VLANs. VLAN, VLAN ID. Name is completely optional. If you want to provide the name, well and good. If you don't want to provide the name, still good. Okay, this doesn't affect. Names are just to show you that whenever you check the configurations, you already know that, okay, these are the departments. Okay. Now, if you check the VLAN configuration, so go to the privilege mode and say show VLAN brief, and you'll see you have VLAN 10 HR, sales, and accounts. Okay. Now, next is if you want to delete the VLANs, even more simple. No VLAN 10, no VLAN 20. No VLAN 30. Check again. Do show VLAN brief. No VLANs available. Is it clear? Now let me create VLAN 10 and VLAN 20. If you check again, do show. This time I didn't give the name. Do show VLAN brief. So by default, it will take the names like this. If you create 10, then VLAN 0010. VLAN 20, 0020. Okay.
And the port we have to assign it manually.
Manually. The port memberships we have to assign manually. Okay, port membership will not be automatically assigned because how your switch will know which port you want to connect in which VLAN, right? So
But
port
you not
membership.
forget like 50-50 kind.
No. There's nothing this 50-50 kind thing. Each and every port membership you'll have to assign manually. Okay.
So like in routers, we have to go in the interface mode and then that's where we assign.
Yeah.
So we don't have
To assign the VLAN membership, we'll go to the interface only. Okay. So let me say VLAN 10 name HR, VLAN 20 name sales. These are the two departments. Okay. Check the VLAN configuration. Do show VLAN brief. VLAN 10 and 20 is there, right? VLAN 10, VLAN 20. Okay. Now what we are going to do, we are going to use some host
Can you override this? And
Yes.
for example, previously you gave just 10, and after that you gave again 10, then one as 6, then it will override the previous one.
Yes, just the name will be changed.
And whatever the configuration.
Configuration will not be removed.
Only name. will be-
Only name.
Okay.
Connect these. 10.0.0.1, 20, 10.0.0.1, 20.0.0.1, 20.0.0.2. Next we have 20.0.0.1 and 20.0.0.2. Okay. Now we are going to provide the membership. So if you see, this is port number F0/1, right? And this is F0/2. Then this is 4 and this is 3. Okay. So we are going to create networks. This is in a different VLAN. And this is in a different VLAN. So port number 1 and 2, I want to add in VLAN. Let's say, for example, VLAN 10. This is my HR department. So VLAN will be 10. And this is my sales department. And VLAN will be 20. So go to the switch and go to the interface. So interface F0/1. You're going to say switch port. First of all, by default, your switch ports are behaving as access port. Okay. And if they are not behaving as access port, you can make them behave switch port mode access. To make a port behave like an access port, you can say switch port mode access. Now to provide the membership, you're going to say switch port access VLAN and your VLAN ID. Switch port access VLAN and VLAN ID. Hit enter. Done. Go to the second port F0/2. Same command, switch port mode access and switch port access VLAN 20. Okay, second also 10. Correct. Now port number 3 and 4, we want to provide VLAN 20. So right now, when I provided VLAN 10, I had to go to one interface, each and every interface individually. You can select multiple interfaces together with the interface range command. Okay, so 3 and 4, I want to combine, right? So F0/3. And what is the last interface? 4. Okay, you don't have to write like F0/4. This is not correct. You cannot write F0/4. This is not correct. Only you have to go with the last number. Okay. So I have selected both the interfaces, interface range and interface numbers. Then I'll say, first of all, switch port mode access. And then switch port access VLAN 20. And you'll see both my interface will come into VLAN 20. Now, if we check the configuration, do show VLAN brief. You can see interface F0/1 and 2, they belong to HR, and 3 and 4, they belong to. This is clear. Okay. To remove the configuration again, you have to say no. So what it is saying? Command rejected. Why? Because we have provided the membership. So let me just go and remove the membership. Okay. And by default, they will be in the access mode. So nothing need this command we don't need to give, because either of mode they will take. And by default, it is access mode and we cannot remove the access mode. Okay. Then similarly, interface range F0/1 to 2, and I'll say no on the same command, just VLAN 10. And now what I'm going to do, no VLAN 10, no VLAN 20. Okay. So if you check the VLAN configuration, do show VLAN brief. Do you see any VLAN? No VLANs. Now what I'm going to do, I'll go and directly give the command, directly try to provide the membership. Okay. So interface range F0/1 to 2, and I'll try to say switch port access VLAN 10. Without creating the VLANs, I'm trying to provide the membership. So what will happen? Your switch will create the VLANs automatically for you. Okay. It will say access VLAN does not exist. So creating the VLAN 10. It will create the VLAN as well as provide the membership also. Okay. Similarly, interface 3 to 4 created. Check again, do show VLAN brief. So created the VLAN as well as provided the membership. Is that clear? So these are different ways to create a VLAN. Either you can create the VLAN, give the name, or the VLAN will automatically be created when you provide the access port membership. Okay. So is it clear? Any doubts so far? Okay. Now what I'm going to do, the same amount of VLANs, the same configuration, I'll copy out this configuration. Okay. I'll just change the IPs. I'll say 10.0.0.3. And here I'll say 10.0.0.4, 20.0.0.3, 20.0.0.4. 3, 4. Again, we are having 3 and 4. And before this, let me show you the broadcast traffic, about the broadcast traffic also. So we have divided these into different VLANs. So if I try to communicate from PC1 to 20 network, if I say ping 20.0.0.1, will I be able to communicate? No, because different networks will not be able to communicate. So there is no communication. And if there is a broadcast traffic, so what I'll do, I'll go to the simulation mode and check where my broadcast traffic is going. So I'll say ping and 10.255.255.255. This is the broadcast address, right? Hit enter. You can see if you open this packet, the destination is broadcast and MAC address is all F. Now what will happen? This broadcast, instead of traveling in the second VLAN, it will just travel in the same VLAN, because we have broken the broadcast domain of your switch. Okay. And if you do not have the VLANs, then what will happen? It will go to the 20 network as well. Let me just show you. So for this demonstration, I'll take one more switch and I'll connect two systems. I'll just copy out the systems. When you copy, see, let's say I'm copying these two systems. So the IP configuration, everything is also copied. If you check. So whenever you press Control and copy out the devices using drag and drop, remember the configurations are also copied. So this is 10 network, this is 20 network. And if I create a broadcast on this side, ping 10.255.255.255. This is a broadcast traffic, and you'll see this will travel in the 20 network as well. Why? Because they are in the same VLAN. Okay. Okay, let's go and check about trunking. So these are the two switches. We have different IP configurations. This is VLAN 10, this is VLAN 10, this one is VLAN 20, and here we are having VLAN 20. If I connect these switches, so now if you see VLAN 10 this side also, VLAN 10 this side also, VLAN 20 this side also, VLAN 20 this side also, right? So if I try to ping from this 10 to this 10, will I be able to ping?
Yes.
Let's check. First of all, I'll try to ping 10.0.0.2. I'm able to ping. But if I try to ping 10.0.0.3, I will not be able to ping. Why? Because they are not in trunk mode. Right? Because your switch ports, they are not acting as a trunk port. So whenever this traffic is coming from this side, coming here to check whether it can forward the traffic. So what will happen? It is belonging to VLAN 10, but this port by default F05, it is in VLAN 1 and acting as a access port. And access port can forward the traffic of one VLAN only. So this will forward the traffic of VLAN 1 only. So if it is in access mode, it will forward the traffic of VLAN 1, means it is not going to forward this message. So what we have to do? We have to create this port as a trunk port. Now, if this port is a trunk port, what will happen? This switch is going to forward the traffic. But again, if you see this side, this port, again access port and VLAN 1, this will drop the traffic, right? So what you can do? You can create it as a trunk port. Once you create it as a trunk port, this will receive the 10 and it is going to forward it here. So two ports we need to create trunk, F0/5 on this switch and the second switch. Okay.
The trunk will be like similar for both 20 and 10 networks.
Yes, only one trunk. One trunk means it is member of all the VLANs, right? So go to the switch, go to the interface F0/5 and say switch port mode trunk. Done. Go on the second switch, CLI, enable configure terminal, interface F0/5 and say switch port mode trunk. Does it have the VLANs? Let's check. Do show VLAN brief. Okay, it is having the VLANs, so no problem. Now, if I try to ping, you'll see I'll have the communication. Earlier, I was not having the communication with 10.0.0.3, but now I have the communication with 10.0.0.3, as well as I have the communication with 10.0.0.4. And also, the second VLAN, sales department, will have the communication with the sales department. I'll say ping 20.0.0.3 having the communication, 20.0.0.4 having the communication. Is it clear how to create VLANs, how to assign the membership, and how to make a port behave as an access port as well as trunk port? For access port, switch port mode access. For trunk port, switch port mode trunk. Access port we are generally going to use to connect the end host, and trunk port we are going to generally use for switch to switch connectivity. So any doubt in today's part?
So,
Yes,
on
please.
this access port 001, we cannot access the other networks.
Which network?
The-
No,
the
you will not be
security.
able to access. Again, inter-VLAN routing. Whenever we are talking about communication between two different networks, we will have to talk about routing. Okay. So we haven't performed any inter-VLAN routing yet, so we are not going to have communication. Is it clear? Any doubts? Okay. Online people, any doubt? Clear to everyone?
Yes, sir.
Okay. All right then. That's all for today. See you guys tomorrow. Have a great day.